Well, hidey ho there, Year 7s, and welcome to our next video. And this one we're looking at exercise, sorry I didn't write that up, so I'll write it now, exercise 2C. We're looking at angles at a point. So, not all angles in a diagram or construction need to be measured directly. So that means we don't actually need to physically get a protractor and measure what the angles are. Sometimes we get special relationships that are created or exist between pairs of angles that are created at a point. So as you can see here, where lines sort of intersect with each other and at a point, it creates different types of angles, and special relationships and conditions are created because of that. All right, and so this allows some angles to be calculated without actually having to measure them directly. All right, even if the diagrams are not drawn to scale or completely accurately, if they're given the right information, we can calculate missing angles. Okay. All right, so I'll talk about these three sort of examples more specifically in a second, but basically what we're talking about here is that using our knowledge of different types of angles can help us find angles that are missing. All right, so for instance, we know that this particular angle here, all right, we'd recognize as a right angle, which is 90 degrees. Okay, now we've got another line that split that 90 degrees into two. All right, but knowing that that whole angle, the whole thing is 90 degrees, means that, just say if that was 50 degrees in there, between this AOB and this angle in here, between these two arms was 50 degrees, we know we know and we'll be able to calculate what this missing angle is, because we know both these angles, the whole angle has to add up to 90, so these two angles have to add up to 90, so this missing angle in here must be 40 degrees, for instance. Okay, same here, if we got rid of this line from O to B, say that wasn't there, we'd have a straight angle. All right, and again, we know, you have this knowledge, straight angles are 180 degrees, and now if we put this line in, it splits it up. Let's just say we're told that that angle is 140 degrees. Okay, calculate this angle. Well, how do we find that angle? Well, we know that's 180. If that's 40, then this must also be 40, because these two have to add up to 180. This one, which I'll talk again in a moment more about these, but when we get two lines intersecting, these two angles in here, and I'll change my color briefly, and even these two angles in here, all right, have a special relationship because of the intersection. And these two angles here are actually the same, and I'll change my color back again, and these two angles here opposite each other are the same. All right, and having that knowledge and understanding helps you calculate missing angles, provided you're given the right information. Sometimes you're not given enough information, you can't calculate it. Never go, for these types of problems, never pull a protractor out and try and measure it. Okay, the diagrams may not be drawn accurately, may not be drawn to scale, so the protractor will make no difference. Okay, you've got to use your knowledge of different types of angles to find answers. All right, so some different types of angles that we have. All right, we've got adjacent angles, side by side. So, for instance, we've got AOB here. Okay, not drawn very straight, but it's there, and BOC. Okay, so they are side by side. Nothing particularly special about it. They're just called adjacent angles. Okay, that's all you really need to know. So just know that they are adjacent angles. Okay, this stuff is more important. So this is the stuff you need to make sure you write down into your note-taking sheets. You've got to know these, okay? So you know your complementary. So like I spoke about before, complementary angles you use when you have an angle where you know the sum is going to be 90 degrees, okay? So pairs of angles that add up to 90 degrees are complementary, all right? So you know that the two angles must add up to 90 degrees, all right? So you can use that information knowing that right angles, they are two complementary angles, so we can add them up, and we need to be able to get 90 degrees out of that. Okay, so if you have one, you'll be able to find the other. We also have supplementary pairs of angles, okay, and these add up to 180 degrees. So it's when you have a straight angle, okay, and same deal, you know if that straight angle is split into two, the angles will again add up to be 180. Don't know what that hand is doing there. Naughty little hand. All right, so the two angles again will add up to 180. All right, so they are supplementary. Okay, so straight angle, 180 degrees. Two angles that add up to 180 degrees are supplementary. All right, two angles that add up to 90 are complementary. A lot of people get them confused. You really work hard at not getting them confused. The way I try and not confuse them is I go alphabet, C becomes before S, 90 becomes before 180, so complementary must be with 90, supplementary with 180. That's sort of the way I go about trying to remember it and not get them confused, because it is easy to confuse. Last one is angles in a revolution add up to 360 degrees. All right, we did that when we were trying to draw reflex angles or measure reflex angles, knowing that again those two angles that we have, one on the outside, one on the inside of the angle, again must add up to 360 degrees. All right, so make sure you know them. Know your complementary, supplementary, and revolution. Haven't finished yet. Couple more. We've also got vertically opposites. This is where we were looking in this first little part, okay, with these two intersecting lines. Vertically opposite. So vertically opposite angles are formed when two lines intersect, okay, just like here. So we've got these two lines here intersecting each other. The opposite angles are equal. Sorry, my pen didn't work then. Okay, so my angle A on this side and my angle A on this side are going to be exactly the same. They are going to equal. Same with my angle B. I'll change my colour. Okay, so my angle, well, that didn't work. Try again. My angle B and my angle B being opposite each other are also going to be equal. So if that's 30 for A here, then this A is going to be 30. If this B is say 120, this B is going to be 120. Okay, so again, really important that you just know that. And it's really important. So you've got to know your complementary, supplementary, revolution. You've got to know your vertically opposite angles. And the last one is perpendicular lines always meet at 90 degrees. And they don't have to cross. We could have like a right angle like that. It's a very poor right angle, but just say if it was. Those lines are perpendicular. Okay, so perpendicular lines always meet at a right angle of 90 degrees. Okay, so make sure you write all those down. Complementary, supplementary, revolution, and I'm repeating myself. Vertical opposite in particular. Have an understanding of perpendicular lines. Very important for you to be able to work through this exercise. All right, what I want you to do, using that information, what type of angle have we got here? I want you to pause it. I want you to work out what angle A is. Show me your working out. What would your working out look like, do you think? Come back and we'll have a look at it very shortly. Off you go. Okay, hopefully you have paused the video and done the work, and let's have a look at the solution. All right, so we know we've got a little box in here that tells us that our whole angle is 90 degrees. Okay, so it is a complementary angle. I'm not going to try and write the whole word because it's too messy. So we know that add up to 90. So if we want to find A, our working out would be A equals 90 minus the angle that we do have, the 35. Okay, which means our answer is going to be, what is it, 55 degrees? I think that's correct. 90 take 5 is 85, take 30, 55 degrees. Make sure we put the degrees in there. Okay, that's simple. All right, so use your knowledge knowing that that's a 90 degree angle, that these two must be complementary, so they have to add up to 90. So take the one we do know away from 90, give you your answer. Okay, and again, this is what your working out should look like. That's modeling. Make sure it looks like that. Okay, same deal. Here we go. Another naughty little hand sitting in there for some reason. Similar problem. I want you to pause, have a go, come back, and we'll go work through the solution together. Again, remember your working out. Okay, what type of angle do we have here? I can hear you all yelling out. It's a straight angle, so it has to equal 180 degrees. So we're looking at a supplementary. Two angles that add up to be 180 degrees, so they're supplementary. So I'll get that out eventually. All right, so again, we know one angle is 55 degrees. So we want to, again, find angle A equals 180 minus our 55 degrees. So that is going to then equal, what is it, 125, I believe. I think that's correct, 180. Yep, that's correct. All right, so 180 minus 55 gives us 125 degrees. So angle A equals 125 degrees. There's our answer. Okay, that easy. Again, that's the working out. That's what you should be modeling. All right, next one, and I think it's our last one. All right, so I want you to have a look at this one as well. So think about this one carefully. Again, I want you to pause it. We're not using a protractor. Without using a protractor, never use a protractor for these problems. I want you to find the missing angle A in here. All right, off you go. Okay, working out's very important, this one. Let's see how you go. So you should be looking at this and thinking, okay, we have a full revolution. Okay, so we're dealing with 360 degrees, which means all these angles, angle A, this 120, and this angle in here, pardon me, all have to add up to 360. Okay, so we know that this is 120. We've got a box in here. So again, you use your knowledge of, okay, that box means that this angle is 90 degrees. Okay, it's a really bad 90, really bad degrees, but we'll work with it. Okay, so same deal. Angle A equals, we're going to start with our 360. We know all three angles have to add up to 360. Okay, we're going to subtract 120 from that, and we're going to subtract this one, which we know is 90 degrees also. Okay, I'm actually going to add these two guys up to make this a little bit easier. So I'm going to have 360 minus, I've got 120 and 90, which is 210. Okay, so I'm going to do 360 minus 210, which is 150 degrees, I believe, should be our answer for that one. All right. Again, really, really simple, but working out is really important. You need to make sure you show you're working out really, really carefully. All right. Maybe on this one you may have done 360 minus the 120 first, and then whatever answer that was, so 240 minus 90 on the next line, which would then give you 150. You could have done it that way. But yeah, show you're working out really, really carefully. All right, make sure it's very, very clear. All right, but again, so not hard to do. Like I said, never use a protractor for these problems because they are not drawn to scale. They're not really drawn accurately. So that's not the right way to go about it. Just use your knowledge of all these different types of different angles, complementary, supplementary, revolutions, vertically opposites, you know, your right angles and straight angles and all that type of stuff to work through each of these types of problems. All right, hopefully that makes sense to you. And again, anything that was confusing, go back and re-watch any of those sections in the video. That's what you can do, or make sure you talk to your teacher. All right, thank you guys, and we'll catch you on the next one. Bye-bye.